Okay, everybody, this lesson is going to be about significant figures. There's going to be a two-part lesson in this one. The learning target for this video is I can count the number of significant figures in a measurement. So let's say in the lab I was doing an experiment and I had three measurements of liquid that I was trying to add together, and I was trying to figure out what the total volume of the liquid was. Now, for some reason, I used three different measurement devices. I had a graduated cylinder right here that was measured at 2.52 milliliters. Remember, this 2 is estimated right here. We got to 2.5 and then estimated the last one. I've got a beaker right here that was measured to 153, and this last digit was estimated there. So I know that I've got 153 milliliters, or I know I've got 150 for sure, and I estimated to 153. And then this last one right here is called a volumetric flask, and it's the bulb, and it's got a very, very, very precise line on there. That's going to tell me that I have exactly 1,000 milliliters, and it's going to estimate to the 0.01. It's very precise, and so I'm going to get that last little decimal place. So let's just say that I get 0.01. And so I'm going to add all of these measurements together and try to figure out how much liquid I have. And so when I take my measurements and I add them all together, I've got 2.52 plus 153 plus 1,000.01, and I end up with 1,155.21 milliliters. And I'm looking at myself and I'm like, man, I measured all of that. Look at how precise I was with all that. I got to the 10th or the 100th place here, the 0.21. I really measured that well. Right, so I know that I have a ton of liquid here, and I know that I have it extremely precise because I look at all these decimal places. Well, the problem is that this measurement right here, I could have 153, I could have 154, I could have 154.02359. I could have anything in here because I don't know this number right here, this little 3. I only know that I have the 150 here, and I estimated the last one. So to report this number, if I was going to go to my lab report and say that this is my answer, somebody might look at this number and they would say, man, this person was really precise, when in all reality, I wasn't precise at all. I measured this measurement right here with a beaker, and so I don't know any of these numbers that come afterwards. And so I can't use this for my answer because it's not that precise. And it shows a level of precision that I didn't have. So this does not work. And so when we're using significant figures, the purpose is to make sure that our measurements, when we add, subtract, multiply, and divide our measurements when we're doing different things in the lab, are only as good as our least precise measurement. So my measurement here, the precision of my experiment, is only as good as this measurement that I made with the beaker. And so we've got to be able to, number one, define how many significant figures, how precise we were in each measurement, right? How precise was this measurement? How precise was this measurement? And how precise was this measurement? And then we've got to be able to take that level of precision and follow it through our calculation. And so the first video that we're going to be doing here is how do we know how much precision we had in each of these measurements? How do we count up this level of significant digits in our measurement? And that's what we're going to be doing here. And so here are your rules for counting significant figures or significant digits. You're going to hear those going back and forth. So non-zero digits are always significant. If I have a number like 542, I am going to say that that has 3 significant, and I'm going to say sig figs, significant figures, because each one of these digits is significant. So if I was counting up the number, 3 sig figs, because none of these numbers are 0. The second rule is any zeros between two significant digits are significant. If I have 505, I would know that this has, again, 3 sig figs, because this is a non-zero number, non-zero, so it is significant. This number is a non-zero number, so it is significant. And this 0 is between two significant digits, and so it is also significant, meaning we measured that 0. We used it. We want to keep that. So we want to notate this as 3 significant figures. If I have something like a trailing 0, let's go to black this time. if I have a trailing zero, so this would be something like a trailing zero, 500. Those two zeros are trailing. Now, we're going to get to a rule on the next slide that says that these two zeros are not significant, but this rule is saying it is significant if it is after a decimal portion of the value. So if I put 5.00, I know that this number is significant because it is non-zero. I know that this 0 right here is significant because it is in the decimal portion of the value. It is in that decimal portion of the value. And so since it comes after this decimal point right here, these two numbers are significant, and this would also have 3 sig figs. Those 3 significant figures. Okay, so those are your rules for significant figures on numbers that are significant. Now, if we're looking at other types of zeros, what types of zeros are not significant? Because remember, all non-zero digits are significant. So now we just got to talk about the zeros. If we have space holding zeros, so if I have a number like 0.0002, these zeros are holding space between our non-zero number and the decimal place. Now they are in the decimal portion of the value, but they're just holding space here, so these are not significant. So this number here would have 1 sig fig, 1 significant figure. If I have the 0 to the left of a decimal, if I have, let's use the same number, 0.0002, the 0 to the left of the decimal is now this one right here. See how this decimal point is here? This one is just taking up that spot there, showing that we have nothing there. That is not a significant figure, and this has 1 sig fig, like I said before. And another example of this one, just so you have a different picture of what this one looks like. If I have something like, let's say 0.123, this has 3 sig figs, because these 3 numbers are all non-zero, so they are significant, meaning 3 significant figures. And this one right here is a non-significant number because it's the 0 to the left of the decimal place. That one has 3 significant figures. If I have trailing zeros on a whole number, those 2 zeros there do not tell me anything, and so these 2 are not significant. This 5 is non-zero, and so that is significant. And so this number here would only have 1 sig fig. Now, I put on here, unless it has a decimal point here. So if I added a decimal point to this, now I put that decimal point specifically there to tell people that I want those zeros counted as being significant. I measured this thing at exactly 500, and so if I put a decimal place after a whole number with zeros trailing on the end of it, this number now has 3 sig figs, because I'm putting that decimal point there saying that I want those zeros counted. And then the last number here is leading zeros in a whole number. If I decided to put let's say 0.102, that only has 3 significant figures. I cannot add precision to my measurements by just putting zeros in front of my numbers. So this has 3 significant figures. So I copied down some of our rules here. We're going to do a little bit of practice. If I put out the number 1010, how many significant figures does this have? Well, this one we can go through our rules, and we can say that this has non-zero digits, so those 2, yes, are significant, and I can say that any zeros between 2 significant digits are significant, and so this one is also significant. Now this one down on the bottom here, this 0, is a trailing 0 on a whole number, so it is not significant. And so if I was going to count the number of sig figs in this one would be 3 significant figures. So let's say I added a decimal point on the end of this, and I also added a 0 out here. Now how many significant figures would that be? Well, we look at our rules again. We have non-zero, non-zero. We have one between 2 significant figures. That doesn't change anything. I have A trailing zero is significant if it's in the decimal portion of the value. Nope, doesn't apply here. I have trailing zeros on a whole number unless there's a decimal point. So I put this decimal point here which says I want this zero counted. So we're going to count that one. And then I have, I decided to put a zero out in front of my whole number. And so right here, this one here is not significant. And this number would have 4 significant figures. I've got my 2 non-zeros, my 0 in between those significant digits, and then I have a 0 with this decimal point right here, making that one a significant figure. Let's say I was going to use this number. So how are we going to count this one? Well, we always look for our non-zero numbers first. So we know that this 2 here is going to be significant. We look, do we have any zeros between 2 significant digits? No, we don't. We have third rule, a trailing 0 is significant if it is in the decimal portion of the value. So that would count for this number right here because it's a trailing 0 and it's in the decimal portion of that value. So we can count that one as significant. Now let's look at this 0 right here. I'm going to put it in red, not meaning that I'm counting it out right now. I'm just going to put it in red. Let's say space holding zeros, not quite so much. Not a space holding 0. That would look something like 0.02. This one is a space holding 0. The 0 to the left of the decimal. Now that one does describe this 0 right here, and so this 0 is not significant, and this number has 2 significant digits. Now let's say I had the number of 0.0002. Right, well, how many significant digits does this have? Let's look at our non-zeros first. Our non-zero digit right here, that's 1 significant figure. We look at all the rest of these 0. This one here is the 0 to the left of a decimal, so that one does not count. And these ones here are space holding 0, so we don't count those either. So this one has 1 significant figure. What happens if I add this 2 right here? Now how many significant figures does this number have? 20.0002. So we look first at our non-zero numbers. We know that we have this one right here. We have those. So those 2 are both significant. I look down, any zeros between 2 significant digits are also significant. Well, this is a significant digit. This is a significant digit. And I would say that from where I'm sitting, those look like they're right between those 2. And so all of these counts. We have 1, 2, 3, 4, 5, 6. 6 significant digits. All because we put that 2 out in the front saying that we measured all of those zeros. We're saying that if we put those 2, all of those zeros between 2 significant digits, we actually measured those zeros. And so I hope this video has helped you to be able to count significant figures. We're going to go over adding, subtracting, multiplying, dividing them in the next video.